Welcome to the class, my dear students. In today's lecture, I am going to find the solution of the heat equation by using the variable separable method. This is the partial differential equation, and the standard equation is a heat equation. So here, what is one partial derivative is the second order, the other is of first order. If that is the case, how to solve? In the previous lecture, I hope you could understand how to solve when the Laplace equation I have taken when both the terms are second order, then how to get the solution. When now this is where that is the difference between first order and there is second order involved, suppose how to find out. So again the same procedure, what we write down first is we assume that the equation has the solution as like this. Now the dependent variable is what here, z, and what is the independent variables are x and t. So let us consider z is equal to x of x and t of t be the solution. Assume that this is the solution of the equation 1, be the solution of the equation 1. So our job is to find out what is this x and t, so that you can plug that in, that will be the solution of the equation. So now let us find out what is dou z by dou x. So what is dou z by dou x? Treating t as a constant, it is x dash t. What is dou z by dou t? It is t is a constant, so x is a constant, so differentiate with respect to t, therefore x t dash. Now in our problem what we need, dou square z by dou x square. So we find out dou square z by dou x square, which is given by x double dash t. And we don't want dou square z by dou t square, so don't do the other one. So always save time, which is not needed, you need not do. Okay. And now let us substitute this, plug these values in the equation 1. So what the equation 1 implies is x double dash t is equal to x t dash. So how can we, now the variable separable method, that means the variables x double dash x and t dash over t we can write. And let us now take this as a constant k. Let us consider this as the constant k. Now our solutions are depending upon the constant k. So how do you say this? This is first case 1. When you take k is greater than 0. So if the constant k is equal to positive, that is k is equal to a square, let us say, then this is positive, right? So what happens to the equation? Now let us call this equation as 2. So to get the solution for this, we consider that x double dash by x is equal to a square and t dash over t is equal to a square. So what is the equation now? We can rewrite this as x double dash is equal to a square x, and that gives you x double dash minus a square x is equal to 0. So what is the operator form? The operator form is, let us write down this bit here. The operator form is d square minus a square of x is equal to 0. So what is the auxiliary equation? Just it is representing the second order differential equation, right? Second order ordinary differential equation type. So what is the auxiliary equation here? Is m square minus a square is equal to 0. And therefore what are the roots here? Is m square is equal to a square, so m is equal to plus or minus a. When the roots are m is plus or minus a, that means the roots are unequal and real. So what is the complementary function? Is nothing but your function now x is c1 e raised to x plus c2 e raised to minus x. So this is what your first one. And now let us go to solve this. T dash by t is equal to a square. So t dash is equal to a square t. So how can you rewrite this? As t dash minus a square t is equal to 0. Now when you write the operator form, it is t dash, remember. So it is just d minus a square of t is equal to 0. Even you can do like this, or by using the first order equation also you can do whatever it is. Even you can write this as a m square, d is replaced by m, So it is m minus a square is equal to 0. So what is m here is equal to a square. That means, remember, this is not of second order. Here it is of second order, whereas here it is not of second order. Understood? So therefore, we can write down this as m is equal to a square only. There is only one root because it is a first order equation, remember. So when there is second order equation, we get two roots. Now it is a first order, only one root will be there. And what is the solution now? The solution is t is equal to just c3 e raised to a square t. Okay, C3 e raised to a square t is the solution because it has only first order, only one root exists, and this is what the solution. Now let us go to do the case 2. Case 2. What is case 2? Is if the constant k is negative, that is k is equal to minus a square, that is less than 0. Then what will you write here? That is k is equal to x double dash by x is minus a square. X double dash by x is equal to minus a square, and t dash by t is also equal to minus a square. So what it implies now? X double dash plus a square x is equal to 0. And what it implies? D square, the operator form, d square plus a square of x is equal to 0. And what that implies? M square plus a square is equal to 0. What that implies? M is equal to plus or minus ai. This is what these are what the roots which are imaginary roots. Therefore, what is the complementary function? Is given by x is equal to c1 cosine ax plus c2 sine ax. Okay. And now let us go to this t dash by t. That implies what? T dash plus a square t is equal to 0. So from here we can write the operator form as the operator form. How can we rewrite this as d plus a square of t is equal to 0. Remember that this is the first order only. So we should be little conscious about this, and don't write m is equal to plus or minus a or something because there is only first order. So what is m here? Minus a square. I got only one value. So now the solution is what? Ct is equal to c3 e power minus a square t. This is what the solution. Remember the difference in the previous problem. The last video I have explained you when there is a second order for both. Now this is the first order. So remember there is m is equal to, the students generally do the mistake here. What is that as? They will write this as minus a square means plus or minus ai as the m. M value itself is minus a square. So you have to write this one. So therefore now what is the solution? The solution is given by z is equal to x into t, right? So it is c1 cosine ax plus c2 sine ax times of c3 e raised to minus a square t. This is the solution. Let us now go to solve with case 3. What is case 3? If the constant k happens to be 0, then that is x double dash by x is equal to t dash by t is equal to 0. So from here what we get? X double dash is 0 and also t dash is equal to 0. And also t dash is equal to 0. So therefore it is d square is 0, therefore m square is 0, therefore the roots are m is equal to 0 comma 0. Therefore what is the complementary function? c1 plus c2 x times of e raised to 0x, which is c1 plus c2 x times of e raised to 0x. Therefore x is equal to c1 plus c2 x alone. And now coming to this part, it is the d is equal to 0. What is the auxiliary equation is 0, and therefore m is only 0. So what is t here? It is just c3 e power 0 t, which is nothing but c3 itself. So therefore now what we can write? The function z is given by x into t, that means c1 plus c2 x times of C3. So this is what the general solution under the case 3 where k is equal to 0. I hope you enjoyed the lecture. Thank you.